Projectile is any object that is given initial velocity. Certain initial velocity is given to that object, and then after that with initial angle also, that is angle theta. Okay, after getting initial velocity and angle, that is the direction, it will follow its own path under the action of gravity and air resistance. But while deriving equations for projectile, we will again ignore air resistance. Okay, there will only be a force, that is acceleration due to gravity, that affects motion of projectile. So look at this figure right here. If you launch a projectile from here, any object, right, with initial velocity b naught right here, with initial with an angle theta with positive x-axis, then it will follow this kinds of path, and this path is said to be trajectory. The path followed by a projectile is said to be trajectory. This is the trajectory, and in general this is the parabolic in nature, right? The projectile, the trajectory of the projectile is parabolic in nature. So look at here, v naught, which is velocity, and it is a it has two components. We can split, this is two-dimensional motion, so we can split into two components. X component is denoted by vx, and y component is denoted by vy, right? So look at first what will be there, what are the conditions, what will be velocity at different point and acceleration. So first thing to know is vertical velocity, vertical acceleration, which we denote by ay, of the projectile motion will remain constant, and which is g. Okay, vertical acceleration of the projectile motion remain constant. This is constant, and g, it is g, right? And horizontal velocity remains constant, so vx will be 0. Not a 0, it is constant, right? Let's say constant. Okay, so along y-axis acceleration will be 0, because you see here, if velocity is constant, there is no change in velocity, it means acceleration should be 0 along x-axis. So these are the few conditions, few things you need to know before deriving or getting equations to find its position and the velocities. Okay, so other thing is, if acceleration is always pointing downward in case of projectile motion, because acceleration due to gravity is pointing towards the center of earth, which is always pointing downward into this direction, right? Remain it constant. Okay, so at this point, which we can call maximum height attained by this projectile, the vertical velocity Vy will be constant. However, the vertical acceleration will be g. Okay, so this is the description of the projectile motion. Now let's derive some relationships that gives you the position and uh, position and velocities, position and velocities of the projectile. Okay, so if you split this vector b, that is initial velocity, into its component, horizontal component is b naught cos theta, right? We know that. And vertical component is b naught sin of theta. So let's go from here. First thing is, what will be the x position? So x position is simply velocity multiplied by time. So x component of this projectile motion is b naught cos theta, and multiplied by t gives you the x position of projectile, right? Let's say this is equation 1, which is the first equation, and the second one is the y position, and y position can be written in the form of one of the kinematic equation. Uh, we derive one of kinematic equation like x equal to b naught t plus half at square. If you just extend this one, what will be the vertical velocity? Vertical velocity is component is v naught sine theta, right? T is same like t, and what is a? A is negative z, so negative half zt square. Okay, so this is the y component of y position of projectile. So let's say this is equation 2. Now let's find x velocities and y velocity. So x velocity is denoted by bx, and as I said, it will remain constant, which is just simple x component b naught cos of theta. So this is equation 3, and y component will change, and it will be we need the velocity, y component of the velocity, which is b naught sine theta, and then negative zt. It's the same like, we have one of the kinematic equation b equal to b naught plus at, right? A is negative z, and b naught, which is the initial velocity, is the initial velocity component, y component of the velocity vector b naught, right? Which is b naught sine theta. So that's how we get this relationship. Okay, so this is relationship 4. So these are the 4 equations that determines the position and the velocities, x component, y component of the velocities of projectile motion. If you look at these equations, starting from the first equation, which is the x position, it depends on, x position depends on initial velocity and angle theta subtended at the origin, right, along with x-axis. Similarly, y position will depends on initial velocity, angle, not only these two, there is third things, right, which is acceleration due to gravity, because it is controlling factor. Acceleration due to gravity is controlling vertical movements, vertical velocity of the projectile. So vertical component of the velocity remains constant, which is p naught cos theta, and sorry, this is the horizontal, right, p naught cos theta, and vertical component of the velocity is this one, right? It is determined by acceleration due to gravity. Not only these things, velocity, initial velocity, and angle, it also depends on the acceleration due to gravity. So these 4 equations are very important equations. So after deriving these 4 equations, let us do something important that is related to projectile motion. Okay, so those things are maximum height that projectile could attain, that is one. The maximum time, that is the time spent by the projectile in air, that is second thing. And the third thing is horizontal distance, how far a projectile can go with initial velocity v naught and making an angle theta with positive x-axis. So our goal now is to find maximum height. I can write down maximum height, then second is time period, time of flight, let's say time of flight, and range, This is horizontal range. Simply you can say range. Okay. So first thing, find the height. It is denoted by capital S. So height is simply distance. So it is the vertical distance covered by the projectile. So we have to take the y component of velocity, and let's say time t1 to reach at maximum height. Okay. So what is the y component of velocity? Y component is b naught sine of theta. And what is time? We can write down time in terms of acceleration. T1 is equal to b naught sine of theta divided by z, right? You have simply the relationship for acceleration. Acceleration is simply velocity divided by time. For time you can say t1. So this is taken as y component. So what is y component? B naught sine theta, right? I can put it here like this, and then t1 is there. Instead of a, acceleration is z. So t1 is equal to b naught sine theta divided by z. That's how we get it, okay, for the time. So I can insert this value here, b naught sine theta divided by z. If I simplify these things, I will get something like this relationship, right? This is the maximum height. Yeah, I forget to add one more term. Let me do right here. Maximum height, one more thing, right? So minus half will be there, and zt square, right? So t1 squared minus half zt1 squared, right? I forget this term. So if I go here and put the value of t, what will be there? B naught square sine square theta divided by z square, right? Z will be cancelled, and the remaining terms are these. So divided by b naught square sine square theta divided by z. Okay, if you calculate this one, you will get b naught square sine square theta divided by 2z, right? This is the maximum height attained by a projectile. So after you get the maximum height, let us find what is the time that projectile is spent in the air. How much time could it be? Could it remain in the air? So you know t1, that is the time to arrive to reach at maximum height, right? So t1 was, as you calculate, sine of theta divided by z, right? So total time denoted by t will be double of this time, because the time required to reach at maximum height and come down to the ground will be same, right? 2t1, so which will be 2b naught sine of theta divided by z. So this is an expression for time of flight. Okay, this is second expression, equation that is relevant to projectile motion. Now last one is the horizontal range. Horizontal range is simply how much distance from the original point to the landing position does projectile cover. That is the range. It is given by horizontal component of velocity multiplied by total time, capital T, right? Time of flight. So what is horizontal component? B naught cos of theta multiplied by what is total time? Total time is 2 b naught sine of theta divided by z, right? That was the time. So b naught is here, and 2 sine theta cos theta divided by z. So what is 2 sine theta cos theta? If you remember trigonometry, this is sine 2 theta, right? So I can write down b naught square sine 2 of theta divided by 2. This is the horizontal range. Okay, so overall we get three equations that gives you three very important thing related to the projectile motion. So this is the horizontal range, that is the maximum range, maximum distance horizontally covered by the projectile, and one was time period, which was 2 b naught sine of theta divided by z, right? And another one was the height, maximum height, b naught square divided sine square theta divided by z, 2z, right? So these are three important equations. So if you look at these three equations, what will you see? You will see in all of them there are in the right hand side one variable that is included here is b naught, initial velocity in all equations, right? Second thing is angle theta and theta. These are two things that determines maximum height, time of flight, and the horizontal range of the projectile motion. Okay, so now let's find at what angle projectile could have maximum range. Suppose that what I am trying to talk is, suppose that you throw a projectile with 30-degree, you throw with some 45-degree, right? And you throw some with 60-degree. This is 60-degree, right? So if you do that, at which angle projectile will have maximum range? That is our question. So maximum range is possible only when sine theta 2 theta is equal to 1, right? It will be possible only when sine 2 theta is 90-degree, right? If 2 theta is 90, then sine 90 will be 1. So theta will be 90 divided by 2, which is 45-degree. Okay, so all the other angles the projectile motion could not have maximum range with same initial velocity and initial angle. So it will be maximum if you are practicing, for some sports and you have to throw something, competing to throw something far from here. Your angle should be accurate, right? That is 45 with same strength, same initial velocity. If your angle is 45-degree, it will attain maximum range r. Okay, however, you put the extra force, maybe initial velocity is little bit more, but if your angle is something other than the 45-degree, then you cannot have maximum range.